the 249 sister trans and one R3S.
Right.
So I just was kind of curious, like how, if we don't, there's no RNS,
Okay, so let's see, what was it?
1R3S.
Let me come back to that. So it's 1,3-dichloro.
Yeah.
Okay, so 1 and 3-dichloro.
1 ethyl.
1 ethyl. Okay. And so the first thing we would have to do then for this molecule is we have to write it. We have to write it so that carbon number 1 is, what was it? RS. R, and then the other one was S. Okay, so if we have to basically put our bold and dash wedges to make this R. You could, if you wanted to, just, I don't know, I'll guess. So how about I put a bold wedge to the ethyl group and a dashed wedge to the chlorine, and let's see what I get. Down here I would have my chlorine attached there. So you can guess, if you're right, you got the right R. If what I wrote is S, switch to bold and dashed wedges. So in this case, number 1 is the chlorine, and then I've got to deal with all 3 of these groups, carbon groups. So this is a C. So this carbon is a C. That carbon's a C. That carbon's a C. This is a carbon with 2 H's and a C versus 2 H's and a C versus 2 H's and a C. That wasn't helpful because now they're all tied. But now we just continue on to the next point. So that's going to be this one, which is going to be 2 H's and a C. This one, which is going to be a C, an H, and a Cl. And then over here, what do I have? I got 3 H's. So now I'm going to compare those groups. Is there any one atom that singularly wins? Cl. So that's number 2. 2 H's and a C versus 3 H's. 2 H's and a C wins number 3. That one's number 4. So then I just have to switch my groups so that I can determine R and S. So I'll switch 1 and 4 and 2 and 3. I now made 2 switches. Whatever I determine now is okay. Going from 1 to 2 to 3 is what? Let's actually switch 1 and 4. Switch 1 and 4, 4 goes there, 1 goes there. Going from 1 to 2 to 3 is still counterclockwise. And so I drew S. So what did I do? I gave the ethyl a bold. Let's give it a dashed. Let's give the chlorine a bold. So that one is now R. Got to do the same thing down here. I think it's easier at this point. I'm going to make the chlorine bold, and I'm going to make the hydrogen dashed. That one's number 4. That one's number 1. As I go around the rings this way, I've got what? 2 H's and a C. 2 H's and a C untied. I now go up here. That wins versus that one. That carbon has a chlorine and a carbon and another carbon versus 2 H's and a C. So that means this group is going to be number 2. That group is going to be number 3. In this case, what did I get? I got S, so I guessed right. And if I didn't guess right, I would just simply change the bold and dashed. Okay. So that's not the answer. That doesn't get us to the answer yet. That's just the first part. So let's just draw that structure, and now the question is, where do I go from here? Where I go from here is I now have to convert this into my chair. So now I have a chair. Or wait, the question was whether they were cis or trans, right? I don't need the chair. I don't need the chair. Are the two chlorines cis or are they trans? They're cis. And we never talked about the size of halogens. Like who's bigger, an ethyl group or a chlorine? They might be comparable because halogens are bigger than alkyl groups. So we'll just leave it at that. So when you're writing out and when you're converting from name to structure, you first of all just have to write the structure out, and then if it says R or S, you can make a choice, and then if you're correct, great. If you're not, just switch the bold and dashed, because that's what you're going to have to do anyway. So that's how we would do that one.